Danny, thanks for coming back on the show.
Thank you for having me today.
So today we're talking about Apollo, which is the company's real-time motion detection technology based on neural network algorithms. Could you just explain how Apollo controls and analyzes radio wave transmissions to construct these 3D images?
Sure, we'll be glad to. So Apollo, again, although users probably heard and read plenty about it, I'll just recap shortly here. Apollo is a intelligent computer vision system. It basically shoots radio waves, everywhere or to the scanned area, and the reflections, analyzes the reflections that return using advanced neural network software, constructing a 3D imaging of the scanned area. Because Apollo can detect a very tiny, small volumetric changes, it can easily identify living entities, stationary objects, shapes, and everything like this similar. Because also Apollo has been trained to identify objects and also situations, it can also identify quickly, alert, and do all kind of other nifty things after basically scanning the area and getting the information. So in a nutshell, Apollo is very smart computer vision system that can be used in a wide variety of domains. For example, it can detect see through walls because it's based on radio waves, so it penetrates walls. It can work to a medium like water, like air, even underground. We of course foresee many possible applications for Apollo. For example, even measuring people in a room, measuring their vitals. It can actually, just by sending the radio waves, can measure humans' pulse, heart rate, even oxygen, detect fall, etc. So it has vast amount, and all this wearable-less, so people do not have to wear anything for that. You just put a box in the room, and it's like a router size, and everything is done from there. It can put all these images, of course, on a computer monitor, and you can actually see live in real time the scanned area. Apollo also, beside the medical, Apollo can be used in many other domains. If it's for one of the biggest ones is, of course, autonomous vehicles, smart vehicles. Here, although today we already see that the world is moving into this direction, it's almost every second car today start to have what we call driving assistance system. It's a good system. It's work on ultrasonic and some sensors and motions, and it's all very good. But Apollo here can actually provide a great replacement or a great advancement by basically constantly scanning, for example, in the radius around the vehicle. It can do it even for a mile or two, a larger distance, and provide an accurate information what is going on, and of course based on that make decision. We believe that Apollo can be a great solution for autonomous vehicles, for smart cars, and of course we can does lots of other good things, see in the dark, it can also count people in a conference room and alert, go into installed in airports and detect concealed object of interest, identify facial features, and also identify persons of interest. So we really have find intruders that are breaking into locations. So there's a vast amount of domains Apollo can be used, and we just now started to look into some other aspects to actually try to get a feel by maybe building some internal projects, prototypes to learn more what are the capabilities. But sorry for that, I can talk about Apollo for 2 hours, so I will stop here.
Just before we get into the company's recent testing, could you talk a bit about how artificial intelligence technology works with Apollo?
Of course. So the data that come back from the reflection of the radio waves is basically has all type of other information, which is technical. And this is fed into the neural network, and the neural network is trained already, pre-trained and trained as it goes. As it goes with the scanning and sending the transmission. So the neural network, the artificial intelligence, has a few algorithms inside it. I can just mention a few. For example, random forest. We're using also k-means. We use actually few known algorithms that we a little bit modified, customized to our own derivative, I call it, and construct an image. So that's the beauty of an AI. Basically, I can take a trained data and I can train a model and say, oh, okay, now I can identify this is a cat. So if Apollo sends radio transmission, got in return some feedback, which the reflections constructed some patterns, and of course the Apollo vector does a lot of other things that I'm not, as I say, I can talk 2 hours about it. Pixelation, vectoration, do all kind of things. But then at least, okay, after that, it reasons and say, okay, I can reach a conclusion. This is a cat. This is a human being. This is the heart rate of the human being, the heart rate of the cat. This person fell. Or if it's a car, I can identify, a child jumping, 100 feet ahead. I better alert the computer to slow, to stop, etc. It's an emergency situation. So Apollo sees very well radio waves and see, to medium thing doesn't affect by weather condition, by light condition. It's just go forward. And the AI here is of course, integral. This is actually where the wisdom comes to support the radio, to make actually sense of the imaging around it. So again, I just mentioned a few algorithms that we use here, but we have our own derivative of this. And again, that's in a nutshell about the AI behind Apollo.
Can you discuss GBT's recent testing of Apollo in identifying obstacles on train tracks and how that might apply to what you mentioned earlier with autonomous driving and application in cars?
Well, as you said, Apollo has a potential to do many things. It can alert the driver if he falls asleep because it detects the face, it detects the different in heart rate and rhythm of breathing, all these type of things. But one of the main nice things that Apollo can do very well is obstacle detection. That's not only trains, it's also cars, it's also motorcycles, everywhere under the water. So it can do really a lot of good things, especially with that. So one of the, and of course, there's a lot to be done here. I mean, we could spend millions here. Okay, let's start to build prototypes and this and this and this domain. But we came to a decision to actually try to get feel about the efficiency of Apollo system by modeling basically, for example, a train simulator, what we call it. One of the nice things that we thought about is trains, okay, same as autonomous vehicle, but more defined, they have tracks. Apollo system can be a perfect system to actually find, if a tree fell on the track, if somebody crossed the track too close, a car stuck, anything that a human maybe doesn't see or doesn't see well from far or close, the Apollo can see very quick, get an alert, or even furthermore, might actually take some action. So same as autonomous vehicles. So we have, we decided to, what we do a small scale testing, build a little prototyping simulator of a little train model that we actually going to try to build a little, use the basic circuitry of Apollo, to get the feel how it looks really in the field. And if it works, of course, on the simulator, you just multiply it, by times 87, and you can, do it on a real train. In the same way we can do, of course, on a regular car. The car is a bit more difficult because we may need more complicated circuitries. There's more investment into it as a prototype. But the decision to actually go ahead and do it on a small scale train simulator is affordable, is doable, and we can get the feel of the power of the Apollo system. And that's the decision we took. So we're going to try to see how Apollo, what's the efficiency level, etc., detecting obstacles for trains.
Now, you've mentioned a lot of the potential applications of Apollo. What do you see becoming sort of the main use cases for it?
I think that the reason we decided to go with optical detection because we foresee Apollo is a great candidate for all type of warning, obstacle avoidance, collision avoidance for vehicles, autonomous vehicles, or even standard vehicles. It doesn't have to be autonomous. You can take a box of Apollo, put in any car, and all of a sudden you have a great intelligent system that can alert in real time. Okay, I see this, this what's going on around you. And of course, it can be also in the future implemented within autonomous vehicles to actually take action, push the brakes, steer the wheel, slow the car, etc. So this is one of the major fields that we see Apollo as a great potential is vehicles, obstacle detection, collision avoidance, systems, security and warning for vehicles, maybe a driver alerting system, fall asleep or any emotional distress, Apollo can detect. That's inside the car cabin. So in the automotive, I would say, or in the vehicles, in the transportation system, we foresee Apollo as a great player with the great advantages.
All right, Danny, that's actually all I have for questions today. Did you have anything else you want to add?
I believe we covered it all, but just again, one last word about the Apollo. We believe that, currently the world already has, we see cars flooded with sensors. We have ultrasonic, we have LIDAR, we have many, and they all work well. But we believe that Apollo takes one step further. Apollo doesn't depend on any other things like weather conditions or light visibilities, or it works anywhere, all the time, and to mediums. It works fast, it's in real time, and radio waves are definitely, especially in this shape, in this format, many frequencies. It's a very, we call it a reliable system. And that's the key word of Apollo is reliability. We believe it has the highest reliability, probably the highest accuracy. That's what we're going to start to test now. And we foresee the Apollo system as an upgrade for the current, sensing system that you can see in vehicles and just normal cars. Even new cars today have come, rear control warning, etc. We see it one step further, even a few steps further. And we believe that it can be easily and nicely and efficiently implement within vehicles, and that's the direction we're going into.